I've looked at solving real-world problems algebraically using functions, and I want to be able to solve real-world problems using graphical methods too. So let's do that. So maybe I've got a graph that looks like this. I'm going to stick with position versus time. So maybe I've got position versus time in seconds. And this is a person who is moving along. So maybe they are moving like this for a little while, and then they speed up. So now they're moving faster, and then they kind of slow down again. So there is my function of time. And I want to be able to answer questions like, well, let's grab some times first. Here's 1, 2, 3. 1, 2, 3. We're not doing any kind of a shifted scale or anything like that. So maybe I want to be able to answer a question like, where was the person after 5 seconds? So I'm going to pull right here, 1, 2, 3, 4, 5. Here's 5 seconds. Here's where my function is. That's where the person was after 5 seconds. They are at x equals 1. We're going to need units on this. Let's call this thing meters. They're at x equals 1 meter. Maybe I want to know, where's the person after 10 seconds? I'm going to do the same thing. 5, 6, 7, 8, 9, 10. They are right here. That is at x equals 1, 2, 3, 4 meters. And then I can ask a question that's something like this. I've already done separately the backwards thing, right? Like, at what time is this person at x equals 5 meters? Actually, let's do that. So I'm asked when. Because I'm asked when, I know I'm looking for the time, so I'm looking for the horizontal variable when x is 5 meters. So when x is 5 meters, I'm going to draw my line, 3, 4, 5, and I'm looking for where my function meets that, which is right at this location. This location happens at t equals 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. T equals 15 seconds. Last question that I want to be able to do with this. What is represented by x of 12 minus x of 2? Now if you remember the thing inside the parentheses here, this is the argument of my function. And the argument of my function is this horizontal variable. So this is saying what is represented by x, which was my position, of 12. So when t equals 12, this is my position at t equals 12 seconds minus my position at t equals 2 seconds. There's my 2. So this is how far I moved between t equals 2 seconds and t equals 12 seconds. If I wanted to actually solve that, at t equals 2 seconds, I am, let's go with green, I am here. That looks like I'm at x equals half a meter. At t equals 12 seconds, so 10, 11, 12, I'm here. That looks like x equals 1, 2, 3, 4. Let's call that 4.5. So the difference between those 4.5 minus a half is 4. So x of 12 minus x of 2 is about 4 meters. I moved about 4 meters during that stretch of time. That's how I solve these graphically.